So here we have A1 and A2, G1 and G2, and H1 and H2. Now each of the pairs are two arithmetic, two geometric, and two harmonic means between two quantities A and B. So using this information, we need to prove the following statement. So let us begin with whatever we are being provided with. Okay, so here we are given that we have two numbers A and B. So it's given here that A1 and A2 are the arithmetic means between A and B. So we have A1 followed by A2 and then B. So these four numbers are in arithmetic progression. Then what we can do, we can find out the value of A1 and A2. So for this, we are going to suppose that the common difference, or because it's an arithmetic progression, therefore we'll have a common difference. So let the common difference be denoted by the letter D in lower case, such that we have A1. So A1 will be defined as we take the first term, which is A, and add the common difference D to it. Then we can find out A2. So A2 will be simply equals to, we'll take the previous term, which is A1, and add one common difference to it. So that means we have A plus 2D. Then we can also define the fourth term, which is B. The fourth term is nothing but take the previous term, which is A2 in our case. We have A plus 2D, and if we add one common difference, that should give us the fourth term, which is B. So that means we have A plus 3D. Now, using this particular equation, we can find out D from here. So D will be nothing but B minus A over 3. So now that we have the value of D in terms of B and A, what we can do, we can replace it in place of D in A1 and the D in A2 to get the value of A1 and A2. So let's do that. So here we have A plus, so in place of D, we have B minus A divided by 3. So this is going to be equals to, we have 2A plus B divided by 3. Then we have A2. So A2 is simply A plus 2 times D. So D is B minus A divided by 3. So this will be equals to, here we have A plus 2B divided by 3. So we have obtained the value of A1 and A2. So let's write it down neatly. So we have A1 equals to 2A plus B divided by 3. And then we have the value of A2. So A2 came out to be A plus 2B divided by 3. Now we're going to keep it aside and we're going to work with the geometric mean. So here we have A, G1, G2. So G1 and G2 are the geometric mean that has been inserted between A and B, such that these four terms, A, G1, so this is the new thing that we're working on, A, G1, G2, and B, these four numbers are in geometric progression. Fine. Now, if they are in geometric progression, then definitely it's going to have a common ratio. So we're going to define the common ratio by the letter R in lower case. That means we can define G1 as we have to take the first term or the previous term and multiply it with the common ratio R. So A times R is going to give us G1. Then we can define G2. G2 will be simply take the previous term, which is G1, and multiply the common ratio to it. So that means we have A times R multiplied to R. So that's going to be AR squared. Using the same idea, we can also define the last term or the fourth term B. So B will be simply take the third term, which is G2 AR squared, and multiply with the common ratio to get AR cube. Now from here, we can define R as B over A whole raised to the power of 1/3, or we can say the cube root of B over A. That's the common ratio. Now what we'll do, we'll substitute this value in place of R here. So that's going to give us A times, we have B over A whole raised to the power of 1/3. So that's going to be A times, so we're going to combine this A in the numerator and this in the denominator. So that's going to be A raised to the power of 2/3 times B raised to the power of 1/3. Similarly, we will replace the value of R with the cube root of B over A. So G2 is going to become A raised to the power of 1/3 multiplied to B raised to the power of 2/3. So now we have obtained the value of G1 and G2. So G1 is A raised to the power of 2/3 times B raised to the power of 1/3. And then we have G2. So G2 will be A raised to the power of 1/3 multiplied to B raised to the power of 2/3. Fine. Now we'll come to the terms H1 and H2, which are the harmonic mean introduced between A and B. So let's work with the harmonic mean now. So we have the four terms A, then we have h1, followed by h2, and then we have b. So these four numbers are in harmonic progression. Since a, h1, h2, and b are in harmonic progression, so then the reciprocal of each of the terms, so we have 1 over a, followed by 1 over h1, then we have 1 over h2, and then we have 1 over b. So these terms are going to be in arithmetic progression. So since they are in arithmetic progression, so it's going to have a common difference. So let the common difference be denoted by the letter D in uppercase. And now we can define 1 over h1. So that's the second term. That's simply take the previous term, which is 1 over a, and add the common difference d to it. Then we can also define the third term, which is 1 over h2. We'll take the previous term, which is 1 over h1, and add the common difference to it. So that means we have 1 over a plus d. And when we add one more d to it, we'll get 2d. And then we have the fourth term, which is 1 over b. That's defined as the first term plus 3 times d. So from here, we can find out the value of d. So d will be simply equals to, so we have 1 over b minus 1 over a, all multiplied to 1/3, or simply we have a minus b divided by 3 times ab. So that's the value of the common difference d, which we will substitute in place of 1 over h1 equals to 1 over a plus d. So this will be 1 over a added to a minus b divided by 3ab. So this is going to give us a value. So we have the common denominator, that's 3ab. So here in the first term we have 3b, added to it will be a minus b. So that gives us a plus 2b divided by 3ab. So that's the value of 1 over h1. Then let's also find out the value of 1 over h2. So this will be 1 over a added to 2 times a minus b. We're replacing the value of d with a minus b over 3ab. So that's equals to, we have 3ab, then in the numerator we have 3b plus 2a minus 2b. So that will be 2a plus b divided by 3ab. Now that we have the value of, or the reciprocal of h1 and h2, so we can find out h1. So h1 will be simply 3ab divided by a plus 2b. And we have h2, so that's the reciprocal of 1 over h2, which is simply 3ab divided by 2a plus b. So now that we have the value of h1, h2, we have also found out the value of g1, g2, and we have a1 and a2. So now we can verify the statement. So let us begin. So we start with the first part. So let's first find out the value from the left hand side. So on the left hand side, in the numerator, we have g1 times g2. So g1, that's simply a raised to the power of 2/3, multiplied to it is b raised to the power of 1/3. And we have g2 multiplied to it. So that's simply a raised to the power of 1/3 times b raised to the power of 2/3 divided by, we have the product of the two harmonic means. So we have h1 and h2. So we have 3ab multiplied to it is a plus 2b. And then h2, so that's 3ab divided by a plus 2b. Now we're going to use the law of the exponents to multiply a raised to the power of 2/3 and a raised to the power of 1/3. So the powers will get added. Similarly for b, we have b raised to the power of 1/3 added to 2/3 whole divided by, we have 3ab times 3ab, so that's 9a squared b squared, and then whole divided by, so we have so this is 2a plus b, so we have a plus 2b multiplied to 2a plus b. Fine, so that's going to give us ab in the numerator divided by 9a squared b squared, and this two expression will go into the numerator. So we have a plus 2b multiplied to 2a plus b. So here we can factor out ab from the numerator and the denominator, and that leaves us with a plus 2b multiplied to 2a plus b in the numerator, and in the denominator we have 9ab. Okay, so that's the left hand side. Now we'll work with the right hand side. So we have a1 plus a2 divided by h1 plus h2. So let's substitute the value. So a1 is 2a plus b divided by 3. Then here we have a2, so that's a plus 2b divided by 3. Whole divided by h1 plus h2. So we have 3ab divided by a plus 2b. Added to it will be 3ab divided by 2a plus b. So that's equals to, so in the numerator, let's take 1 over 3 as the common factor. So we have 2a plus b. Added to it will be a plus 2b. Then in the denominator, we can take 3ab as the common factor, such that we have 1 over a plus 2b added to 1 over 2a plus b. So here we can have 1 over, so this 3 will get multiplied with this 3 to give us 1 over 9ab. Then we have 2a plus a, so that's 3a, plus b plus 2b, so that's 3b. Divided by, now when we combine 1 over a plus 2b with 1 over 2a plus b, we're going to get 3a plus 3b divided by the product of a plus 2b times 2a plus b. So luckily, we can factor out 3a plus 2b from the numerator and the denominator. And finally, we are left with a plus 2b times 2a plus b divided by 9ab. And we see that we get exactly the same expression. So that means we can say that the left-hand side is going to be equals to the right-hand side. So this is verified. Let's go to the second statement. So we'll start with the product a1 times h2. So we have a1 multiplied to h2. So a1 is 2a plus b divided by 3. Multiplied to is as h2. h2 is 3ab divided by 2a plus b. So we can factor out 2a plus b from the numerator and the denominator, and also 3, and that leaves us with simply ab. So this is equivalent to ab. So that part is verified. Now let's come to a2 multiplied to h1. So a2 is a plus 2b divided by 3. And then we have h1, which is simply 3ab divided by a plus 2b. So this will be also equivalent to ab, because we can see here that a plus 2b gets factored out and the 3 also gets factored out. And then finally we have g1 times g2. So g1 is a raised to the power of 2/3 times b raised to the power of 1/3. Multiplied to it will be a raised to the power of 1/3 times b raised to the power of 2/3. So let's combine these two a. So here the base is the same, so that means the power is going to get added, or the exponent gets added. Similarly for the b, the base is the same, so we can add the exponent. So we have 1 over 3 multiplied to 2 over 3. So 2 over 3 plus 1/3, that's simply 1. So we have a times b. So g1 times g2, that's also equals to ab. And we can say that these three products are equivalent to each other, and all of them have the same value, a, b. And hence we have successfully showed that this particular statement is also true.